Hi everyone and welcome to today's video. Today we're going to be learning about how to find the square root of a complex number. It's going to be an easy topic, I encourage you. So let's learn something new. Get your cup of coffee, sit down, get your notebook. Let's learn something new. Alright, square root of a complex number. So that's what you're looking at today. The square root of a complex number gives a pair of complex numbers whose square is the original complex number. Just like the square root of a natural number comes in pairs. Alright, so this is more like the other square roots of different numbers. So what happens is the answers you expect are going to be two different answers, and we're saying that the square of those two answers that we get is going to give us the original number when you square them. So that's basically it for complex numbers. So we expect two answers when you do calculations. Alright, so it's gonna make sense when you look at some different examples. So determine the square root of a complex number. 3 plus 4i is our first question. So how do we do this? So the first step is we're going to let that root, we're going to let the square root of 3 plus 4i to be equal to a plus bi. So a plus bi is the final answer that we're looking for, but we just don't know what the values of a and b are gonna be. But we're going to let that be the square root of 3 plus 4i. So this is going to be what represents the square root of 3 plus 4i. So let's solve this. Alright, so when we square both sides, let's get rid of that square root. When we square both sides, we get this. So the square root here disappears and cancels with the 2, and then we remain with 3 plus 4i. And then on this side, when we have this, when we square these digits in brackets, it expands and we have that. But we remember that I squared is negative 1. So because of that, this becomes negative b squared. Alright, so now the next thing we do is we're going to arrange the real sides together and the imaginary sides together. What that simply means is we're going to separate the values that have an I and the values that don't have an I on them. So you can actually see that the b squared does not have an I on it, so we bring it together with the a squared. So this is also a real part. So now the real part becomes this, and this becomes the imaginary part. So then after that, we can now compare the two different sides of the equal sign. So we're going to equate the real to real and the imaginary to imaginary. So when we equate the real to real, we can see that 3 is equal to a squared minus b squared. And then we can also see that when we equate the imaginary, we can also see that 4i is equal to 2ab I, and that is going to be equation 2. So we have the a squared minus b squared is equal to 3 being equation 1, and then 4i being equal to 2abi being equation 2. So from equation 2, we can actually see that the i's can cancel, then we remain with 4 is equal to 2ab, and then making b the subject, we can see that b is equal to 4 over 2a. So now we are going to work out to solve this step by step, because now the goal is we need to get the value of a and the value of b. Alright, so now we know that b is equal to 2 over a, because you can actually see that the 4 divides the 2, and then we remain with a 2 at the numerator and an a at the denominator. So we have equation 3 as b is equal to 2 over a. But substituting for b in equation 1, we can actually see that equation 1 was being a squared minus b squared is equal to 3. When we substitute the value of b, we end up having that. Then when we square those brackets, we have 4 over a squared. Alright, so now we can find the LCM. When you find the LCM here, we can actually see that the LCM is a squared. And then what happens is here we're going to have an imaginary one. So a squared divided by 1 is a squared, and then a squared times a squared is a power 4. And then a squared divided by a squared is 1. 1 times 4 is 4. So this is what we end up with after LCM. And then next you can see that cross multiplying can happen. Then a squared and 3, we have a cross multiplication there. Then we end up with a power 4 minus 4 is equal to 3a squared. So let's bring the 3a squared to the left hand side of the equal sign, and then leave a 0 on the opposite side of the equal sign. So end up with this equation. So now we're going to use this equation to solve for a. But before we do that, let's simplify this equation a little bit. So as you can see, the a power 4 can be is similar to a squared squared, as you can see there. So now we're going to let x represent a squared in that equation. Okay, So what happens is this. So we're going to let x represent s squared. So we'll end up with that. So wherever there is s squared, we're going to put x, and then we end up with this equation. Now this is a quadratic equation that we can now solve using the quadratic formula. So remember the quadratic formula, we're going to use that to find the value of x. So when you substitute those values into the quadratic formula, this is what we end up with. Then when we simplify that, we remain with root of 25, which is equal to 5. So end up having two different values of x. So x is either equal to 3 over 2 plus or minus 5 over 2, which can both be simplified that way. So as you can see, 3 over 2 plus 5 over 2 is equal to positive 4, and then 3 over 2 minus 5 over 2 is equal to negative 1. So we end up having two values of x. Alright, so now from s squared is equal to 4, so remember that one of the values of s squared is equal to 4, we can see that s squared is equal to 4. So we can see that a will either be positive or minus 2. And then from s squared is equal to negative 1, we can actually see that a squared is equal to negative 1. Okay, but now when we try to eliminate the squared by finding the square root on both sides, we can actually see that root of negative 1 is equal to I. So we end up having positive or negative I, because root of negative 1 actually represents an I. So we end up having two different answers of A. Alright, now substituting for A in equation 3, remember equation 3 we had B is equal to 2A. Now we want to find the value of B. Now let's try to use the example of this. So let's test this out. So when A is equal to 2, we can see that B is equal to 1. And then when A is equal to negative 2, because there are two different answers from here, positive or negative 2, we can actually see that B is equal to negative 1. Now let's try it out also using this. What if we use this side of it? So from when A is equal to I, let's say A is equal to positive I, we can actually see that this actually happens. So when we substitute that, we know that B is equal to 2 over A, of which now A is going to be equal to I. But now this is not in the form A plus BI, so we need to simplify this. So how do we do that? We multiply both top and bottom by the conjugate of the bottom, of which the conjugate is negative 1. So we end up with this. So when we do that, we end up having negative 2i at the top, and then at the bottom, this will actually disappear, because I times negative I is going to be equal to negative I squared, of which I squared is a negative 1, and negative 1 times negative is going to be positive 1. So we have negative 2i over 1, which is just basically 2i. Alright, so when A is equal to negative I, we also have it that way, and then we'll end up with a positive 2i as our answer after solving. Alright, now we're going to use either of these to solve and find out now what the square root actually is. So if we use the answers that we get from this first part, from the value of A being positive or equal to negative 2, we end up with that. Now we substitute the value of 2. So remember that when A was equal to 2, B was equal to 1. So we substitute the value of A as 2 and the value of B as 1. So end up having that as our one of the answers. So there are two answers to the square root, and then now we can also see when we substitute A as being equal to negative 2, we end up having that, and then B is equal to negative 1, so we have that. So the square root values are that. Now we can also see that also using the answers that we actually have here, and we also substitute those in, we also end up having that. As you can see that Z is equal to I minus 2I squared. Now why is that? You can actually see that from here, when A is equal to I substitute the value of A as I, and then I substitute the value of B as negative 2i, but you can see there's already an I here, so negative 2i times I becomes negative 2i squared. So that's why we have a squared here. But we also know that a squared means a negative. We know that an I represents a root of negative 1, of which an I squared represents negative 1. So negative 1 times this becomes a positive, so we end up having I plus 2, which is the same as 2 plus I. Or we can also see that in the other way, when we use this, we can actually see that negative I is the A, and then we have B as 2I. So we end up having 2i squared because there's an I here. And then we end up with negative I minus 2, which is equal to negative 2 minus I. As you can see, what happens is when we use the values of a that we get from this second part, or the values of a that we get from this first part, you can actually see that they both give us the two same answers. You can actually compare the two. So I just did it twice for confirmation for you to understand how it works. But as you can see finally that the square root of 3 plus 4i is 2 plus I, or negative 2 minus I. So coming into the future numbers, I will not need to necessarily do both parts. I will not need to compare with this again. Doing it with this is enough. So I will only use one of the sides. So it's optional for you. But that's how I find the square root of 3 plus 4i. Alright, let's move on to question number 2. So we're being asked to determine the square root of a complex number 35 minus 12i. So we're going to let that the square root of 35 minus 12i also be equal to a plus bi, of which when we square both sides we end up with that. So when we open brackets, that's what we end up with. As you can see, I squared is negative 1, so obviously we have a negative b squared. And then when we work that out, collecting the real and imaginary parts, we end up having that. So equating real and imaginary, we also end up having that. So these are the imaginary sides. That's going to be the equation 1. And then now we have the the first ones were the real, and then this is now the imaginary. So from equation 2 we can see that 12i is equal to 2abi. We end up having that, the i's cancel, and then making b the subject, you can actually see that b will end up being equal to 6 over a. So that's going to be our equation 3. Substituting for b in equation 1, we can actually see that we'll end up with that. So find the LCM, and then we'll end up with that. So cross multiply. After cross multiplying, we end up having that. So let's bring the values of a together on the other side of the equal sign, then leaving a 0 on the right hand side. So we end up with that. So now we also know that a power 4 can be simplified to be a squared squared. So like that. So we're going to let x to be equal to a squared. And then when we do that, we can also see that we end up with this quadratic equation. So again, from quadratic formula, we can substitute the values of the quadratic formula, and then we end up with that. Then we can see that x shall be equal to 35 plus or minus root of 1369 over 2. And then the root of 1369 is equal to 37. So we end up having that. So x has two values. X is either equal to 35 over 2 plus or minus 37 over 2. So when you calculate both sides, you can see that x is either equal to 36 or x is equal to negative 1. So let's look at one of the options. So from a squared is equal to 36. So because we know that x represents a squared, so we're now going to use this. So a squared is going to be equal to 36. So we know that the square root of 36 is positive or negative 6. So substituting for a in equation 3, we can actually see that b shall be equal to 6 over a. Right, so what happens there? We know that when a is equal to 6, let's go with the a being equal to positive 6. We can also see that 6 over 6 is positive 1. So when a is equal to negative 6, we can actually see that b is going to be equal to negative 1. Now in this case, I'm not going to try to use this other side because it won't be necessary, because it will just give me the same answer. So because when I consider a squared is equal to negative 1, the answers will basically be the same. So I'll focus on this side, and then now we have these two values of b, and those are enough for us to find the square roots. So from z is equal to a plus bi, you can see that z shall be equal to 6 plus I, because when a was 6, b was equal to 1, and then we can also see that when a was negative 6, b was equal to negative 1. So we end up with the square root of 35 minus 12i being equal to 6 plus I, or negative 6 minus I. And hence that's how we find the square root of different numbers. Alright, so let's move to another part. Let's look at equality of complex numbers. So this is how it works. Two complex numbers are said to be equal if and only if they have equal real parts and equal imaginary parts. For example, if the complex numbers z1 is equal to a plus bi and z2 is equal to c plus di are equal, then a is equal to c and b is equal to d. Now what this simply means is that the real parts are going to be equal. that A is going to be equal to C means the real parts are equal, and B being equal to D means the imaginary parts are equal. So I've tried to mention a little bit of that. So I gave you a hint of that when we were working on square root, but we're going to go into more detail in this section. So let's look at the question that we're given. So given that x and y are real numbers, find the values of x and y which satisfy the equation 2y plus 4i over 2x plus y minus y over x minus I is equal to 0. So when someone sees this question, it looks scary, it looks big and massive, but this is actually an easy number that we can solve. So what we're going to do is we're going to first take some of the values to the right side of the equal sign so that it's actually easier to solve. So there are many ways to do this. I could have just started working out with LCM, but you know what? I can take the fraction y over x minus I to the right hand side of the equal sign. So I can end up with that, as you can see there. So next I can actually cross multiply. So when I cross multiply, I end up with that. So next I can open the brackets. So when I open the brackets, this is what I end up with. As you can see from right here, that I squared is actually equal to -1. So -1 times this negative makes this a positive. So we end up having a positive 4 right there. Alright, so when we simplify this, we can actually see that if I bring this 2xy to this other side, you can actually see that this and this will cancel. So we end up remaining with this. Now, as you can see, there is actually no imaginary part on this other side of the equal sign, but that's okay. That means the imaginary part is equal to 0. Now what we're going to do is on this other side of the left hand side, we're also going to group the real parts together. So when you group the real part, now the real part is only equal to +4, and then this and this, the 2yi, negative 2yi plus 4xi represent the imaginary part right here. So we end up with that. So let me group this together, because now this represents the imaginary. Now probably here the imaginary was equal to 0i, so -0i, of which we may never know. But so let's compare the real and imaginary parts. So comparing real parts, you can actually see that y squared is going to be equal to +4, because y squared represents the real part on the right hand side, and then the real part on the left hand side is equal to 4. So you can actually see that the square root of 4 is 2. So we end up knowing that y is equal to 2. So comparing the imaginary parts, you can actually see that the imaginary parts on the right hand side are equal to 0. So we have 2yi minus 4xi being equal to 0. So when we work this out, we can actually see that we can actually take the 4xi to the other side, then the I values cancel, but remember that y is equal to 2. So that means that we can actually substitute it in. So 4x is equal to 2 times 2, and then when we make x the subject, you can actually see that x is going to be equal to 1, and hence we've actually solved that number. So we're just asked to simplify the values of x and y, and that's actually how you do it. Alright, let's look at a number from UNEB 2006. This was question 9b. So we're being asked, given that x and y are real numbers, find the values of x and y which satisfy the equation x over 2 plus 3i minus y over 3 minus 2i, which is equal to 6 plus 2i over 1 plus 8i. Now this is a little bit more complex than the one before, but it's also doable. As you can see on this left hand side, we have the x and y values with their fractions subtracting themselves, but on the right hand side we actually have two complex numbers dividing each other. Now what we're going to do is we're going to find the LCM on the left hand side, but also on the right hand side we're going to simplify this equation so that it's easier to work with. So how do we do this? As you can see that on this other left hand side, we can just start working out LCM. So I would not cross multiply yet, because it will actually make our calculation more heavy. How can I say, more hectic to work with? So it's better to first leave them as it is until I simplify what's on the right hand side. As you can see, the LCM here is going to be equal to 2 plus 3i over 3 minus 2i. As you can see, this divided by this is going to be equal to that, so this multiplies that. Then we also have this divided by this being equal to 2 plus 3i, so end up with 2 plus 3i times y, which is that. And then on the right hand side, you can actually see that when you're working with division of complex numbers, we multiply both the top and bottom by the conjugate of the bottom. So that's why we have the top and bottom being multiplied by 1 minus 8i. As you can see, when I open brackets here, this is what I end up with, and then I also end up with this on the right hand side. As you can see, I have negative 48i plus 2i, which will give me a negative 46i, and then also this I squared is equal to negative 1, so we end up having a positive 16. So right at the bottom also you can see that this and this cancel, and then I squared is equal to negative 1. So negative 1 times this negative is a positive, so we end up having 64 plus 1, which is that. And then when I open brackets here, this just ends up being that. And then right here at the bottom, we can also see that negative 4i plus 9i is equal to 5i. And then a negative 6i squared, we know that I squared means negative 1. So negative 1 times this negative becomes a positive. So we end up having a positive 6. Alright, so when you keep on simplifying that, you can actually see that this 6 plus 6 is going to be equal to 12. And then right here, 64 plus 1 is 65. And then we can actually see that 6 plus 16 is equal to 22. So we end up having 22 minus 46i. Now this is looking better. Now I can now cross multiply here. So when I cross multiply, I end up having this. But then I would not rush to opening brackets here, because now I'll have something more heavy and complicated. And that will actually make me susceptible to making some errors. So what I'm going to do is, on the left hand side, I'll first keep this as it is. Then I'm going to first deal with the right hand side. So on the right hand side, these are two complex numbers multiplying each other. So let's multiply them. So when we do that, we end up having that. So we can actually see that I squared is equal to negative 1. So when we simplify this, and then negative 552i plus 110i is going to be equal to negative 442i. Of course, here I squared is equal to negative 1. Negative 1 times a negative is a positive. So end up being left with 230. Alright, so now what I'm going to do is, on the left hand side, I'm just going to group the, instead of multiplying the 65 within, I'm going to group the items in brackets. I'm going to group the imaginary parts together and the real parts together. So the imaginary parts are this 3x and this negative 2y, and then the imaginary parts are negative 2xi minus 3xyi. So this is what we end up with. And then what I'm going to do is, I'm going to put each one of them in individual brackets, so end up with something like that. Now for that, I can now assign the 65 to both of them. So we have this, and this looks better, so this will be easier to work with. So as you can see on the right hand side, 264 plus 230 is 494, so we end up having that. So now we can actually see that we've grouped the real parts together on the left hand side and the real parts together, real and imaginary parts together on the right hand side. So now we can equate. So now equating and comparing real parts, we can actually see that 65 into 3x minus 2y is equal to 494. As you can see, I can now divide the 65 on both sides. So 494 divided by 65 is 7.6. Now this is going to be easier to work with. Alright, comparing imaginary parts, we also have that. Now you can see that the I values cancel, and then 442 divided by 65 is 6.8. So end up having this as the second equation. So making x the subject in equation 1, we can actually see that this is equation 1. We can actually see that x shall be equal to 7.6 plus 2y over 3. So substituting for x into equation 2, we'll end up having that. So I can now find the LCM. So when I open brackets, you can actually see that I'll have 15.2 plus 4y. And then when I find the LCM is 3, and then the 3 will multiply the 3y, which is going to be equal to 9y. So end up having that. So now I can cross multiply. 3 times 6.8 shall be equal to 20.4. So end up having this. So when I solve this, I can now divide both sides. Or actually 20.4 minus 15.2 is equal to 5.2. So now dividing both sides by 13, I end up having y as 0.4. Alright, so substituting for y into equation 1, you can actually see that this is equation 1. So we're going to end up having that, and then I'll end up making 3x a subject. 7.6 plus 0.8 is 8.4, and then x is going to be equal to 2.8. Now once I've reached this level, I've actually solved the equation as easy as that. Alright, let's look at a question from UNEB 2014, and this was question 9a. So we're being told, given the complex number z and its conjugate z with a bar, satisfy the equation this: z bar plus 2iz is equal to 12 plus 6i. Find z. Now this is the same thing, so this is also an example of equality of complex numbers. It's just stated a little bit differently. Now what we're going to do is, in this case, we're going to let z be equal to x plus yi. Now in former examples, we've been using the letters a and the letters b, but I want you to know that you can actually use any two letters of your choice. So for this case, we're just going to use x and y, and I believe that is okay. So now if we let z to be equal to x plus yi, obviously its conjugate is going to have a negative in front of the imaginary, so the conjugate is definitely going to be x minus yi. So that's basically the opposite of that. So this is our equation right here. So now we can substitute the value of z and the value of the conjugate into that equation, so end up having that. So obviously the main goal is we're going to first solve for x and y, and then we'll find the values of z. So let's open brackets here. So as you can see, when I multiply these two complex numbers right here, I end up having that, and then when I open these brackets, I also end up having that. Right now there is a lot happening within here, so it's better to be careful so that you don't make any mistakes. As you can see, this and this cancel, and so we are left with that. Now the next step is, we know that I squared represents -1, and since it does that, so this is going to become -2y, and then this section is going to become positive y squared, and then we end up having that. Now the next part is, I can group the real parts and imaginary parts together, and then I end up having that. Now on the left hand side, the only imaginary part is 2xi, so I'm going to group the -2y with these other values. So these now represent the real part, and now this alone represents the imaginary part. Now on the right hand side, the imaginary part is, the real part is equal to 12, and the imaginary part is equal to 6i. Right, so comparing imaginary parts, you can actually see that 2xi is equal to 6i. The reason I'm going to begin with the imaginary parts is, I can see clearly that I can easily get the value of x directly through that, so it will speed up the process. So you can actually see that we will have 2x being equal to 6, and then x shall be equal to 3. Now, so now that we know one of the values, we can easily find the value of y. Right, so when you compare the real parts equate to that, but now we know the value of x. So we have that. So substitute the value of x in, and then we end up having that. As you can see, now I can convert this into a quadratic equation, and this is what I end up with. Now this can be solved using the quadratic formula. So we're going to find the value of y using the quadratic formula. So substituting the values in, I can see that I'll end up with y is equal to 2 plus or minus root of 16 over 2. But root of 16 is equal to 4. So this is what I end up with. So now I can divide 2 on both sides, and then I'll end up having that. So my answers are either 1 plus 2 or 1 minus 2. Right, so the two values of y are now equal to, y is equal to 3 or y is equal to -1. Alright, so therefore z is either equal to 3 plus 3i or z is equal to 3 minus I. So now we'll have two different values of z because y has two different values, but of course x stays the same. So I have x as 3 here, and then I have y as 3. Then I also have that where x is 3 and y is equal to -1. So there will be two values of z, and hence we've solved the number. Right, so I have some trial numbers for you that you can try out. So try this out and get better. So I've put some answers right there for you to compare your final answers with, so that you will know that you're on the right track. So try this out and get better at finding square roots and then solving this part of equality of complex numbers. So this is the final answer right there. Alright, thank you for watching. Thank you so much for watching this video. Thank you for watching to the very end. I am very, very grateful. I hope this video has blessed you and that it has improved your knowledge of complex numbers. If you really enjoyed this video, or if it really helped you, feel free to leave a like on the video. And then if you're new to this channel, I encourage you to join our community by clicking on the subscribe button and then joining it, and then make sure to hit the notification bell so that every single time I upload a new video, you'll get updates on your notifications. See you in my next video.